Okay, the next thing I want to do after I have figured out how to write a program that prints something is I want to take a programming language and figure out how I get input. And there are two kinds of input I'm generally interested in. One is from the command line, as in I have some prompt and I want to run a program, and I want to put out here some option -x3. Those are command line arguments. That's the first way. The second way that I want to be able to get input to a program is I want to be able to read a file. The way that Unix treats socket connections and other things is they are all reading and writing files. So when I've done these two things, I have a way to configure my program. I have a way to tell it to read and access not just files on the file system, but a lot of stuff having to do with the network as well. Now there's more to a socket connection than just reading a file, but this gives me the basis of being able to process stuff. Certainly in the model that was the simplest model for computation, what we did long ago is you had a bunch of files that you input into a program and it produced a bunch of files as output. And that's what we called batch processing. And as I'm working up to more complicated things, this is what I want to start off with, is the 1960s model of compile a program, get some configuration, read a file. And the first thing that I would generally do is I would want to write an echo program. Echo basically takes the command line arguments and prints them back out to me. Because by the time I write an echo program where I can say $echo X, Y, Z and get back X, Y, Z as output, I have figured out how to access this stuff that I'm going to need for configuration. So echo. This is the next thing that I would do. And it's your next thing in your homework too. So once I have gotten this piece done and I can access some configuration. Now this may not be the only way you might want to access configuration. In Windows they've got this thing called the registry. Oh my goodness, the assumptions built into the registry and the ugly truth about the registry. Ugh. In any case, this is the simplest one. And this is the one we're going to stick with because this works across different platforms. And by and large, this is the way most things are configured in the land of servers. Now, it would be nice if we had some sort of package. There is one built into Go for parsing the command line. But at some point, you just want to say, get the command line, read it in, and print it out. Now, in the process of printing it out, let's say that you have more than two arguments. You've got 1, 2, 3 here. You'd like to get 1, 2, 3 out here. Now, the way Unix treats this is the 0th argument, this is the 1, this is the 2 argument in an array of pointers at strings. And most operating systems have copied that. Certainly Linux copies that from Unix. Windows mostly copies that. So this means that when we get inside the program, not only are we going to end up building some code, but we're going to have our first loop. And we're going to need to start that loop not at 0, because then we'd get echo XYZ 1, 2, 3, or something else that has echo in it probably. But we're going to need to actually be able to say start with something. So inside the main program in Go, we'll do for, and we can declare things on the fly in Go. So I'll say I :equals, this is not equals because the colon says declare this based on the type on the right hand side, 1, and a semicolon, and I is less than the length of this OS argv, and then I++. Okay, now, this should be for, not fon. Apologize for that. And let's see, these are semicolons for separating this. Go only has one looping construct, for. There are just different flavors of it. This is the kind where you have an initialization, a test, and an increment. You can also have for where you just have a loop. You don't have any semicolons and it just says for and an expression. You can have no test at all, as in an infinite loop, and you just do for squiggle bracket. And there is no loop until, because the designers of Go did some actual research and figured out that people are much more prone to making errors if they put the test at the bottom of loops. So they just got rid of that. That's it. And then you want to do a printf on the inside. fmt.printf. And you want to print out the string that you're interested in. Probably with a blank somewhere in here. And a comma. And when you do a printf, you need to know what to reference. So the %s substitutes in, and you do os.argv, the length of it. No, I have made a mistake here. os.argv sub I. There we go. You notice there's no semicolon at the end, and then the end squiggle bracket for the end of the loop. And I did make a mistake up here. This should not be this. It should be the length of os.argv. In any case, you don't have to wonder about this. I gave you the code inside the homework exercise. You would be better off if you retyped it so that you could make some mistakes along the way. But you can cut and paste it right out of the exercise and get this to work. And run it once, and it has an example of how you do a loop in the language. And this is the next kind of a construct I'm always after. Is either I want to know how you do if-elses and cases, or I want to know how you do loops. And this is how you get output and do a loop, how you declare your first variable in here. This is a declaration. There are declarations that are not like this. You can say var name and a type. Okay, but here's one kind of a declaration. Now the interesting thing about this I declaration here is the scope of I is just this little piece of code right here. After the end of the squiggle bracket, that variable no longer exists. Go will not let you declare variables and not use them. It does flow analysis for you on your code, as well as a bunch of other static analysis. So it prevents you from making a lot of errors. And that's a good thing. It takes a little bit of getting used to. Another thing that seems to bother people from other languages is that there are no parentheses here. Okay? The parentheses are unnecessary. It's just making you type for the fun of making you type. And you don't need that either. So Go has gotten rid of a bunch of these typing for the sake of typing syntax markers. And you type less, you get more code done that's actually productive as opposed to just syntactic sugar.